Here's integrated 3. It's problem number 10-98. It says, according to the school secretary, the size of the graduating class of their high school has steadily increased since the school opened. She claims that the number of graduates each year forms the sequence T of n equals 12n plus 30, where n is the number of years the high school has had students graduate. At the end of the year, the administration mails out invitations to all previous graduates to attend the upcoming ceremonies. So the question was asked about letter C. So it asks you a couple questions here, and then letter C is what we're interested in. Letter C says the number of graduates after n years can be represented by this graph at the right. If the Alumni Relations Committee wants to invite all graduates to a party to celebrate the nth anniversary of the school, how many invitations will they need to send? Well, that's a little tricky. By this time, you should have noticed that this is not a geometric series. This is a arithmetic series because it's going up steadily. And you can see that this is like y equals mx plus b. This is a linear model, and so that's why this stack looks like it goes up in a straight line. It's not like not like a exponential growth. So what we've done with the arithmetic series is we found out that you can stack these stacks right here. You can take this one and stack it on top of this one, find out how tall it is, and then it turns out you can like take half of like these taller stacks and you can kind of flip them upside down and they'll stack perfectly with the shorter stacks. And I'm calling those pairs. I've been calling those pairs. But you can see, you can pair up the last half of the bigger half of the data with the smaller half of the data and make like a little rectangle. And then you can find your total. And we've been modeling that since this is arithmetic, we've been saying it's the first, whatever the first term is, plus the last term, times however many pairs of terms there are. This only works for arithmetic, not for geometric series. So I'm just gonna, since I recognize that this is an arithmetic series, I'm just gonna look at it and go ahead and sum it up using this formula. I know the first term would be just plugging a 1 in here. So 12 times 1 is 12, plus 30, that made 42. And the last term would just be, well, we don't know like what n is, so we're just going to leave it as n. But this would give me the last term, 12n plus 30. So this is the first term plus the last term times however many pairs there are. Okay, so I went ahead and added the 42 and the 30 and got 72 to clean this up a little bit. And then I went ahead and just divided. Notice these are even numbers here, so I thought it would clean it up a little bit by just dividing these by the 2 to get rid of the 2. So now I have 32 plus 6n. And then I noticed when I checked my answer, your book has it where they just distributed. So this is the answer. So now actually if you did find out how many years after graduation it's going to be, you could plug your number in right there and find out how many people are going to show up.